Hi, good evening, everyone. I hope my voice is clearly audible. You can simply raise your hands to confirm this. All right, great, great. All right, guys. So today is your extra class, right? And today we are going to discuss about the topic moments. All right. So just give me a moment. I'll simply share my screen, and then we'll proceed ahead with the discussions. Right, and I hope this is needless to mention that if any one of you is having any queries during the session, you are free to ask in the chat section. I'll be addressing your doubts one by one. All right, guys. So moments, as it like moments, this is one of the most important topics when it comes to the uh, right? So moment is one of the most important topics when it comes to statistics, right? It it falls under the category of descriptive statistics, right? So before we proceed ahead with the moments, although I've already walked you through the types of statistics that we have, right? So I'll just give you an overview again about these statistics. So basically, we have four types of statistics, right? The first is the descriptive statistics, right? In descriptive statistics, we basically see the description of the data, or it basically describes your data set, right? When I say it describes your data, so it basically describes your data in statistical terms, right? And when it comes to statistical terms, it's nothing but will basically have this basic description of the data. For example, like the kind of statistics that you'll have when you'll see the when you'll go through the descriptive statistics, or when you'll basically describe your data. So the statistical figures that you'll have will be, let's say you'll have these starting with mean of the data, right? Mean is nothing but the average, right? Average value of every respective column. Let's say your data will basically be in some or the other kind of tabular format, right? So these kind of tables, these are called tables in SQL, right? These are called worksheets when you work with Excel. Okay, just give me a moment. Right. All right, so these are referred to as, let's say, worksheets when you work with Microsoft Excel, right? At the same time, these are referred to as tables when you work with SQL, right? So this will be covered in the coming times. These are referred to as data frames, right? When you'll work with pandas in Python, right? So the complete machine learning that you're going to do, the tabular format in which your data will be represented will be data frames. All right. So there are various, let's say, various nomenclature that is being given, right? Nomenclature is nothing but the names those are provided with respect to various, let's say, various softwares or tools that you're using to represent your data. All right. So these will be basically your data frames in Python, right? These are worksheets in Excel. These are tables in SQL, and so on. All right. So for each of these columns, you'll get the descriptive statistics. Whenever you say you'll be working on descriptive statistics, right? There's a function called describe. In pandas, right? This describe function gives you a basic descriptive statistics of the data, right? Where it will give you the mean of every column. It will also give you the minimum value, maximum value, and let's say this will also give you about the information about the quartiles, right? And in other terms, these are nothing but the percentiles, right? So I hope everyone is well aware of these two terms as of now, right? Because these topics have been covered in your previous sessions. Right. So guys, I hope everyone is able to hear me very clearly. You can simply raise your hands to confirm this. All right. All right. Right. So yes, until now you have been basically the sessions that you are having are named as Excel and statistics, right? So you are in the right session, right? Don't worry. This is basically the even the mean, minimum, maximum, quartiles, everything that we have been doing, right? It falls into the category of statistics, but we need a platform to implement all these concepts, right? So these concepts are implemented on Microsoft Excel, right? In addition to this, I've also walked you through various functions that you can use, right, to analyze your data, right? So this is the first step where your data analysis starts, right? Data analysis is a single term, but let's say when you do a data analysis on a particular data set, right, there can be endless number of methods and techniques that can be used to understand your data in a better way. All right. So just to give you a walkover once again, today we are going to discuss about the moments, right? And before we start the moments, you need to understand into which category moments fall into, right? Now, moving ahead, there are basically 4 types of statistics, starting with the descriptive statistics, which is the first type of statistics, right? Here we'll basically have the basic description of the data, right? When you use methods and statistical methods and techniques to describe your data set, right? So basically, you'll have various statistical figures when you proceed ahead with the data analysis, right? And also, like, this does not end here only. There are multiple other methods, those are used. All right. Next is when you proceed ahead with the data analysis, you need to know the shape of the data. Shape basically tells you how many rows and columns you are handling in the data set. Because according to this only, you will be proceeding ahead. The first will be the selection of your tool that you will use to analyze your data. And then proceeding ahead with that, you will also need to know the shape of the data so that you get to know how much memory consumption, or let's say how much resource from your local system will be utilized when you run any operation on your complete data set, right? So let's say, for example, if I run this maximum function, right, I try to find maximum value of any particular column, I need to know how many rows or how many number of elements I need to iterate over to get to the maximum value, right? So the total number of rows that your data has, it has to iterate over each of these values to compare 2 values at a time and pick the maximum possible value, right? So in this way only, if any function that you're running on your complete data set, right, you need to know what is the amount of memory that will be consumed, right? So this information is also provided, right? It falls into the category of descriptive statistics. And then you find the terms like median, right, mode. You also find terms like variance, how your data is varying, right? You have something called standard deviation, right? You have something called skewness. This will basically tell you. And then you have kurtosis of the data, right? So this part, starting with variance, skewness, and kurtosis, these are basically moments of the data. And apart from this, we also have mean of the data, right? So mean is referred to as the first moment, right? Variance is referred to as second moment in the data. Skewness is the third moment, and kurtosis is the fourth moment in the data, right? So we basically have 4 types of moments. All right, so we'll be discussing all these terms in detail in today's session. All right, and before that, let me walk you through the other types of statistics that we have. The second type of statistics is the inferential statistics. Right, in inferential statistics, we majorly study about relationships. Right, we majorly study about relationships and relationship between, since my data is in tabular format, it's present in the form of rows and columns. So I'll be analyzing the relationship between the columns. All right. So here we'll learn about covariance and correlation. All right. So these 2 terms we are going to discuss in tomorrow's session. All right. we are going to discuss in tomorrow's session about these two terms. What exactly is correlation and covariance? Right. Now, proceeding ahead with this, we have the third type of statistics, which is called as predictive statistics or predictive analytics. Right? Predictive analytics or predictive statistics. So predictive statistics is basically when you'll right. So predictive statistics is basically when you'll make predictions of future based on past data. All right. So here also there are various methods and techniques available, right? So when we make, let's say I give you, let's take a very simple example, right? So for example, let's say if I take, let's say if I give you the stock price data, if I give you the stock price data for past 10 years, right? And it will be available until today, right? Or maybe until yesterday, right? So Saturdays, the stock market is basically closed, right? So until Friday, you'll have this data. And let's say I want you to predict, make a prediction, what will be the stock price of any, maybe Google, right? On Monday, right? The day market opens, what will be the stock price, right? So this is basically, we are trying to make prediction of the future based on past data. Right. So this is nothing but this is machine learning that you're going to learn. Right. Predictive analytics is nothing but the machine learning part. It's complete machine learning. There are multiple algorithms that can be used. They serve different purposes under different circumstances. Right. So this is purely based on the data set that you're handling, right? The kind of data set that you're working on. And basically, it depends on various other factors. And then you'll decide your machine learning algorithm. Let's say you have, for example, let's say you have, just an example, let's say you have 10 algorithms, right? So out of these 10 algorithms, which one you'll have to use for the data set that you are working on? This purely depends on the kind of data you're working with, right? Of course, the target variable is nothing but this is the column that you will predict, right? This is the column that you'll predict. All right, so this falls into the window of machine learning. You'll learn this very soon. Next, we have the fourth type of statistics, which is the prescriptive statistics. Now, in the prescriptive statistics, what happens is we basically prescribe, right? Prescription is nothing but suggestions that you'll give purely based on the analysis of the data, right? The insights that you'll have from the data analysis or the machine learning models, you'll prescribe or suggest some improvements that can be done into the current business model so that you'll be able to make better predictions, you'll be able to grow your business, and eventually you'll attract more customers, right? So this falls into the window of prescriptive statistics, right? So let's get back to our original topic, which is today we are going to discuss about moments. All right, so let's proceed ahead with the discussions. Let me see if we are getting any doubts here. All right, so here, basically, there are 4 types of moments, right? The first moment is referred to as the mean of the data. Second moment is referred to as variance of the data, right? The third moment is referred to as the skewness, and fourth moment is referred to as kurtosis, right? So there are mathematical formulations using which you can easily calculate these moments. The idea here is to understand the intuition behind all these terms, right? Because you have a very single line function to calculate all these statistics on any given data. It does not matter what is the size of the data that you're handling. It does not matter how many rows and columns your data has. You only have a single line function, be it, let's say, Excel, right? Or be it pandas, be it NumPy, right? Everywhere you have a single line function, right? When I say single line function, it's basically one single function that can be used to calculate all these moments in a fraction of seconds, right? But the idea is, let's say you'll get a figure against all of this, right? So figure is basically a single number, right? It's a number. You have to understand what that number is representing. For that only, you need to understand the concept behind all these terms. Let's proceed ahead, discussing about the first moment, which is the mean of the data, right? Now, you have to understand one thing, that mean is nothing but the average, right? Average of any term or average of any given set of numbers, right? So basically, when we talk about data science, right? So in data science, we are majorly applying scientific techniques on the data set to understand this data, right? And this process is called analysis, right? And this is completely termed as data analysis, right? And when we apply scientific techniques, science is majorly built off, let's say, if we leave apart the biology part, right? We leave apart this, it's basically physics and mathematics. That is involved, right? And in machine learning, we are majorly concentrating on mathematics because we are applying mathematical techniques, right? Statistics, this falls into the category of maths, right? It's a subset of mathematics, right? So in statistics, even in physics, right? We are always interested in distance. We are always interested in distance. Let's say if I tell you that maybe there is some variable a and whose value is 5, right? Just an example, right? Let's say I tell you that there's a variable whose value is 5. What does this basically represent, right? So this basically represent that on a number line, this variable a is present at 5 units distance from the origin, right? Origin always lie at 0, 0, right? The center of the, I'm sure those who are from the mathematical background, you completely understand what is a Cartesian coordinate system. Right? And those who do not understand, you'll understand this in a very short time from now. Right. So it is basically your variable a is present at 5 units distance. 5 units distance from the origin, right? And this unit can be anything, right? This unit can be any measurement of distance, right? But let's say if this coordinate system is if it's representing distance in centimeters, then this will be 5 centimeters. If it's representing in kilometers, it will be 5 kilometers. If this coordinate system is representing the data in miles, this will be 5 miles from origin, right? So this variable here, basically it's present at 5 units distance from the origin, right? So this is, let's say 1, this is 2, this is 3, this is 4, and finally we have our variable a, which is present at 5 units distance, right? So this is, since we are talking about only one dimension here, which is why only this is one dimension number line, 1D number line, right? It's a one-dimensional number line. In the similar way, let's say if we are talking about a two-dimensional data, right? If you're working on maybe 2 dimensions, this is a 2D, where one of your axis represents y-axis and one of your axis represents x, right? So this is basically, this is a normal, this is basically, the convention that we follow here, right? That your horizontal axis is x-axis and your vertical axis is a y-axis. You can represent any point on this. Maybe let's say if you want to represent 5, 5. So as usual, this point is your origin, which is 0, 0, right? So I'll move 5 units in x-axis. So this basically is represented like this, right? So generally we represent a two-dimensional data like this, x, y. So if I'm having 5, 5 as my coordinate, right? So this basically referred to as coordinate, right? So here, if I'm representing my point like this, right? So this will be present at 5, 5. So here x is equals to 5 and y is equals to 5, right? So here, let's say moving, this is 1, this is 2, this is 3, 4, and 5, right? In the similar way, I'll go into the horizontal vertical axis as well. Say 3, 4, and 5, right? So I'll simply draw a line parallel to x-axis, and from 5, I'll draw a line parallel to y-axis like this, right? So wherever these lines intersect, this is the point 5, 5, right? You can measure its distance from origin, right? You can measure this distance. Let's say this distance is some dxy, right? This is just a representation. So dxy, how it can be calculated. This is 5 units, and this is also 5 units, right? This distance is 5 units, and this distance is also 5 units. So you can easily use Pythagoras theorem here, and you can calculate square root of 5 and 5, right? So this will be 5 root 2. This will be the distance of x, y. You can simply replace the value of root 2, and you'll easily get the output, right? So this is how every point is represented. And in the similar way, we are going to represent our data sets or the data that you're handling, right, on various coordinate systems to understand our data, right? And to establish relationships. And once we are able to understand the insights of the data, once we are able to establish the relationships, we will eventually be able to train our machine learning models. And once we are able to train our machine learning models, we can make prediction of the coming times based on the previous data, right? So this is the complete, let's say, this is the complete ideology behind what we are going to study from now, right? And statistics plays a very important role. Statistics is said to be foundation of machine learning, right? Statistics is the foundation of machine learning, and to understand your data, to understand or to work even with your data sets, you need to understand, you need to apply statistical techniques to understand the insights of the data, and then only you can proceed ahead, right? So this is basically considered as the foundation of machine learning. And everywhere in machine learning, you will be applying statistical techniques, right? Even there are some machine learning algorithms like linear regression and logistic regression. These are basically taken from statistics only, right? Linear regression, logistic regression, right? We have decision trees. You learn about all these algorithms in the coming times in your machine learning phase. right? So all these algorithms are part of statistics only, right? If you pick any statistical book, let's say any statistical textbook, right, you'll easily find all these algorithms listed out there, right? But these fall into the category of machine learning, right? In machine learning, also, you'll start learning machine learning with these topics, right? So the first topic that you're going to learn is linear regression, right? And proceeding ahead, you'll learn various other types of algorithms as well. So this is where statistics plays a very important role when it comes to dealing with the data sets, when it comes to dealing with machine learning algorithms, training your machine learning models, and so on and so forth. Right. So here, let's say if I talk about the term mean is nothing but it is the average of the data. Right. For example, let's say I have 5 data points. Let's take an example. Let's say I have 5 data points, maybe 12, 14. Let's take another 14. Let's take 17 and 18. Right. So these are my data points. So here we are always interested in distance, since it is one dimensional, right? Data is present only in one dimension. You'll learn about multiple dimensions as well when you learn about NumPy. Right. NumPy basically stands for numerical Python. Whenever you have numerical data and you're working with Python to analyze or train your models, right, you'll be using NumPy to understand the insights of the data. Here you'll learn about n-dimensional data sets, right? Your data could be in any number of dimensions. That does not depend. And basically, dimension here basically means columns, right? So one column represents one dimension, 2 columns represents 2 dimensions. So let's say in the similar way, if you have 100 columns in your data set, the data is into 100 dimensions, right? It's in 100 dimensions. So this is basically dimensions with respect to data sets. When you'll be working, you'll get to know more about it, right? Let's take about this. So since here we are only having one dimension data, so this is 1D, right? So here also we are purely interested in distance only. What does this 12 represents? This basically represents that this particular data point is present at 12 units of distance from the origin, right? In the similar way, we have 14 and 14 twice, right? Then we have 17, and finally we have 18, right? So all these data points are present at their respective distance from the origin, right? So here, let's say, if I give you not the data set, but only the mean, right? I'm sure nobody has, confusion about what mean is, right? Mean basically represents the average value of the data, right? So let's say if I want to calculate mean over this, you can easily calculate. You can simply add all of these terms together, right? 14 plus 14 plus 17 plus 18, and divided by the total number of elements. So this is 1, 2, 3, 4, and 5. I'll simply divide it by 5. Whatever figure I get will be the mean of the data. All right. So let's say, let's add this, right? So this is 8 plus 7 is 15 plus 4 is 19 plus 4 is 23 plus 2 is 25, right? 5 and 2 plus 1 is 3 plus 1 is 4, 5, 6, 7. This is 75 by 5, right? So you can easily calculate. So 5 times 1 is 5, right? We have carried 2, and finally 25. So 5 times 5 is again 25. So this is the mean of the data, right? In statistical terms, we never write average, right? The technical term for average is mean, and it is represented by Latin symbol mu, right? This is the representation. So we can clearly say mean is 15. All right. Now, the thing is, if we want to write it mathematically in general terms, so how do we write mean? Mean is basically represented or written as summation of xi where I will go from 1 to n divided by n. This is the formula to calculate mean. Right? This is the formula to calculate mean. Right? So here xi's are your variables. All right, xi's are the variables, and this is mu. This is represented. This is basically the representation, right? In Latin, m is written as mu, right? How in English we write m, right? So in Latin we write mu. So this is just a representation that is used overall, right? Worldwide, we basically use this particular symbol to represent our mu, or basically mean. All right. Now, the thing is, let me make this very clear that in your technical interviews, nobody is going to ask you about the formulas, right? No formulas will be asked. You're not in your 10th or 11th standard that you'll be tested on the formulas, right? The thing is, you have to understand how any particular term is being calculated, so that, let's say, if I give you any variation on this, you will be able to understand how the internal terms are varying, right? So for example, let's say if I tell you that for any given data set, mean mu is 20, right? And any given data set, let's say there are 10 elements in that, right? What will happen if I double the value of every element? Let's say initially it was 1, 2, 3, 4, like this up till 10. So these are 10 elements, right? And the mean is 20, right? Now, what will happen? Let's say if I double every value, now your data set becomes 2, 4, 6, 8, 10, and so on up till 20, right? So how will your mean be affected? Right? So these kind of conceptual questions will be asked. All right. So you have to understand these formulas. You don't have to memorize them, right? Nobody is going to ask you the formula, but yes, you should be able to understand how these formulas are working internally, right? Once you are able to understand this, you will be able to, let's say, implement, you'll be able to extract the insights of the data set that you're handling very precisely. All right. So yes, this is the formula for me. I hope everyone is able to follow, right? You can simply, let's say, raise your hands to confirm if you are able to follow what we have been discussing so far. All right, all right. Now, let's proceed ahead with the discussions of, okay, let me just give you an overview, like how mu, if you, let's say, expand this particular formula, right? Summation basically says here, what will happen is, what this particular term basically means is, let me just give me a moment. All right, all right. So basically, what this particular term says, right? What this particular term says about, or how you're going to expand this. Right? How you're going to expand this is basically, I will start from 1 and it will go up till n. N is basically the total number of elements that you have in your data set. Right? So for example, let's say the initial formula that we were discussing, or initial data set that we were discussing, right? This part, which is 12, 14, 14, 17, and 18. Right here, if you expand this particular formula, this says you put the value of 1 here, right? You put the value of 1, so xi becomes x1, right? And then you go up till n, and summation basically says this symbol is basically summation, right? And summation basically is nothing but sum of the numbers, right? So you basically add up all these numbers, let's say x2 plus x3 plus x4 plus x5. So there are only 5 elements in our data set, and finally divided by n. So n is the total number of elements, which is 5. Right? So this will be 5. So this is how this formula is expanded, and each of your values, which is 12, 14, 14, 17, and 18, these values will take the place of x1, x2, x3, x4, and x5, right? Like this. This is how this formula is going to be expanded, and this is how the mean is going to be calculated. All right. So this is referred to as the first moment, which is mean of the data. Right. Let's proceed ahead discussing about the second moment. Right. And before we proceed ahead, the first moment of the data, it basically gives you the average value. Right. Let's say, for example, maybe those who are your working professionals, right? If you go to your HR and let's say you ask for the average salary of the employee, maybe in whichever department you are. Let's say you are in maybe IT department, right? So let's say if you ask your HR about the average salary of the IT department, your HR will do a very simple mathematical operation. That is, he or she will take the salaries of every individual who is working in the organization in the IT department only, right? He will add up all these, he'll add up the salaries, right? And finally, they'll divide it by the total number of employees. Total number of employees, that will only IT department, right? So this is how average salary of an IT department can be found out very easily, right? So this basically gives you the average value of any data set, which is the first moment. Now, second moment is variance. As the term itself says, variance basically tells you about the variation in the data. Variation of data set. All right. So the variation of data set, it basically, when variation is to be calculated, right? Variation is always calculated between two adjacent points, right? So for example, let's say I have 12, 14, 14, 17, and 18, right? So I'll simply calculate, let's say the difference between these two. This is 2, difference between these two, this is 0, difference between these two, this is 3, and difference between these two, this is 1, right? So this is the variation in the data set, right? How my data is varying, right? Or what is basically the difference between 2 points, right? Now, the thing is, variation, if you calculate with respect to 0, right? So the first data point that you have will have a very high variation, right? The difference between 0 and 12 is 12, but the difference between 12 and the next element or next digit is only 2, right? Because 0 is the reference point here, right? Every counting starts with 0, right? If I ask you, let's say, what is the distance? Let's say, if I ask you the distance between Delhi and Mumbai, right? So when you start calculating the distance, you'll always start with 0. It will not happen that you'll start with 100. No, this is wrong, right? You'll always start the counting from 0, right? You'll always start, let's say you come up with maybe it's 1200 kilometers. right? If you say that the distance between Delhi and Mumbai is 1200 kilometers, so this 1200 kilometers you've landed up just because the counting had been started from zero, right? What if, let's say, someone starts your counting from 500, right? So this is technically wrong, but even if you are starting counting from 500, you need to add this to your reference point, right? So if it's originally 1200, you simply have to add 1200 plus 500 because this is your reference point. You'll end up getting 1700, right? But this way, everyone gets confused, right? If I tell you that, let's say the difference between Delhi and Mumbai is distance between Delhi and Mumbai is 1700 kilometers, right? You'll get confused, right? Because originally it is 1200, right? So this is the standard that is set, that you always have to take the reference point as your origin. All right, you always have to take the reference point as origin, right? Now, there's a problem. And the problem is when you deal with statistics, when you're dealing with statistics, the problem of the reference point being taken as zero will be that the difference between the origin and the first point that you're having will be very large with respect to other differences, right? So to tackle this problem, what we do is we will shift this reference point from origin to the mean of the data, right? Why only mean? Because this mean is the average value. This mean is the average value of my data set only. Let's say even if my counting is starting from, let's say, 100,000, right? Then also, and let's say the range, for example, range is the maximum minus minimum value, right? So the range is from 12 to 18 for this particular data set, right? What if my counting starts from 100,000, goes up till maybe 100 or maybe 1 million, right? What if this is the scenario, right? So if this is the scenario, the difference between 0 and 100,000 is 100,000 itself, right? So the first reference, or when I'm taking my reference point as origin, there's a problem. Now, what will happen if I shift this reference point to the mean of the data? The mean of the data will lie in this particular range only, right? Does everyone agree that mean of the data will always lie between the range of the data? You can simply raise your hands to confirm if you agree with this, that mean of the data will always lie in the range of the data set itself, right? Because we are adding the elements of the data only. And when I'm adding these 5 elements and dividing it by the total number of elements, which is 5, this figure will always lie between 12 and 18 because I'm calculating the mean on this data set only, right? This is why what we do is we will shift this reference point to mean of this data set, right? How we will shift this, we are going to discuss this very soon, right? Let's discuss this only. If let's say this is my data points, let's say 12, 14, 14, 17, and 18. These are my data points, right? What I'm doing is, let's say somewhere here I have 0, right? Or the origin of this data. Now, let's say I'm shifting this data point, and let us shift this data point to the mean of the data. Mean we have already calculated. I hope everyone is able to see this color, right? You want me to change this? You can simply mention in the chat section if you're not able to see this color, which is blue, right? So the mean of the data is 15. All right. So this is 15. This will lie somewhere around, it will lie in between 14 and 17, right? So this is my point 15. Now what I'll do is, let's say when I'm shifting this to origin, right? Shifting of coordinate system or the shifting of coordinate system to any point can be done. But there are a few, let's say, changes that you have to make in the data points itself, right? The thing is, let's say when I talk about the mean of the data, it is also with respect to the origin, right? This is 15 units. This is 15 units from origin, right? So if this is 15 units from origin, nothing has changed, right? Now I need to shift this origin from here to here. I'll simply put this here, right? But I have to make changes in the data set itself, right? So how these changes are being made in the data, let's have a look into that. My changes are made. What I'll do is, let's say, if I'm shifting it from 0 to 15, right? So basically, this point becomes 0. Does everyone agree that this point will be 0, 0, because I'm shifting my origin from 0 to point 15, right? You can simply raise your hands if you think this is logically reasonable enough, like this is logically correct. All right. All right. All right. So basically what I'm doing is I'm shifting this to origin here, right? Now, if you look at the distance, let's talk only of the distance, right? So let's say my data point 12, it's present at what amount of distance from the mean of the data? It is how to calculate distance between 2 points. Simply take the difference, right? If I want to calculate distance between these 2 points, I'll simply take the difference. So this difference came out to be 3, right? So this is at 3 units distance, right? Okay. Oh, okay. Some of you says it's 12 minus 15. Let's take it that way, minus 3. If we talk about distance in the opposite direction, right? So this is distance in opposite direction. This is exactly what this negative sign indicates. Whereas this positive sign basically indicates it is in the forward direction, and this negative sign indicates it is in the backward direction. This is the only difference, right? Now, what will happen? So this is basically at 3 units distance, right? In the similar way, these two data points are at 1 unit distance, because we'll simply subtract, let's say 14 minus 15. This is minus 1, right? So this minus 1 is basically 1 unit's distance on the left hand side, right? Or in the negative direction. Right. In the similar way, the point 17 is present at 2 units of distance, right? And 18 is present at 3 units of distance from origin, right? Now, since starting, we are only interested in distances, right? So when it comes to these distances, right? So for example, I'll just repeat this one more time. Let's say this 12 is present at 12 units of distance from origin, right? If this data point 12 is present at 12 units of distance from origin, right? If it is present at 12 units of distance from origin, so this is basically 12, 0, right? Or this is just 12 on the number line, right? In the similar way, this is 12, right? Now, in the similar way, if we apply the same concept in reverse, what will happen is, since this point is present at 3 units of distance from origin, from the mean of the data, and since I'm transforming or I'm shifting my origin to the mean of the data itself, this becomes 0, 0, right? So this new data point becomes 3, right? This data point 14 becomes 1. This also becomes 1, right? In the similar way, 17 is present at 2 units of distance. So this becomes 2, right? And 18 becomes 3, right? So this is the complete concept of shifting of origin to the mean of the data. Basically, you can shift your origin to any point in the complete coordinate system. But for easy calculations and for easy referencing, what we do is we shift the origin of the data to the mean of the data set. This is basically the transformation of origin, and accordingly our data points will be shifted, right? Or my data points will be calculated, right? So let's say you can raise your hands if you are able to understand this, how we are shifting the complete coordinate system or the origin of this data set to the mean of the data, right? It's not complex, it's just a little tricky, right? It's not complex, it's just a little tricky. Just need to understand that if I shift this 0, 0 to 15, so this becomes my 0, 0. And now from here, every other data point will be calculated, right? So this is exactly what we are going to do on every data set that we are dealing with. We'll shift our data, let's say data's reference point to the mean of the data here, not here, right, to here at 15, right? This is basically shifting of origin, right? In technical terms, this is called data transformation, right? You'll see that you will be using the transformation of the data a many number of times when you're dealing with the actual data sets, right? Transformation of the data is done for various reasons, right? One of the prime reason for this is to remove skewness from the data, right? You learn about this, that why skewness is basically it's curse to your data set, right? If you have skewness, you basically cannot train a machine learning model, right? So we'll learn the term skewness very soon, right? Let's get over with the term variance first. All right. Okay, one of you is asking, is it mandatory to consider it only to the mean? So basically, as I've already said, you can shift it to any point in your Cartesian coordinate system, right? Basically, in your coordinate system, you can shift the origin to any point. You can practically do it, right? But for the feasibility of the calculations, for the feasibility of the insights, right? We basically shift the origin to the mean of the data, because if I shift to any other point, this particular thing will not solve the problem I'm facing, right? And the problem that I'm facing is, what is the actual problem? The actual problem is when I'm taking 0 as the reference point, the difference between 0 and the first element is very large. The difference between first element and the origin is very large, right? And when it's, see, in data science is purely a game of numbers. It's a game of numbers, right? And these numbers, they basically represent distance. And when this distance is considered, and if this distance is very large, this particular, the first element and the origin will create something called as bias, right? It will dominate your, let's say, pattern recognition, right? It will dominate your pattern recognition, and in the chain, this is going to dominate your findings, right? So we want to solve this particular problem. I don't want any particular data point to dominate my analysis, to dominate my findings, right? To get over this, what I'll do is I'll shift it to the mean of the data, right? The mean of the data is the most prominent point. This is the most prominent point to which my data point, my reference point can be shifted. I can shift it to median as well. That is not a problem. What is median? Median is basically the middle value in the data set. It is the middle value in the sorted data, right? Median is the middle value in the sorted data, but shifting the reference point to the middle value will not solve my problem. Why this will not solve my problem? Because if I shift my data to the middle value does not indicate that you have 50% and 50% towards both the sides. Let's say this is your median, right? Median value does not indicate that you have 50% of the data on right and 50% of the data on left, which is why if I shift it to the median, the problem will not be solved. The problem is not solved. All right. This problem is not solved. To solve this problem, I'll shift this to the mean of the data. Mean of the data basically says that it is not the middle value. Mean is not the middle value, right? You have to keep this in mind. Mean is not the middle value. It is not the middle value, right? But the thing is, mathematically, let's say mathematically, this is the centroid of the data. If you take all the distances of all the data points from mean towards the left and towards the right, you'll end up getting the mean of the data, right? This is the average value, which is why this is said it is the average value, right? Mean is the average value, and shifting it to the average value will always solve your problem of biasness, right? We never want the data to be shifted to any other point, because my problem, which is that the large values will dominate the predictions, it will dominate the findings, right? This problem will remain as it is, which is why we always shift it to the mean of the data. Right? Now, proceeding ahead, those of you, okay, let me take a few doubts. All right. So is it mandate to consider shifting it to mean? The reference point has been answered. Why do we shift the origin? What is the benefit? This is also answered. All right. So all the doubts until now have been answered. Let's proceed ahead. Now, the thing is, let's say if I give you only the mean of the data, right, which is 15, right, and the data set that we were discussing is 12, 14, 14, 17, and 18. All right. So this is the data that we are discussing, and the mean of this data is 15, right? Now, the thing is, there could be multiple data sets that can carry the same mean, right? For example, let's say we can have 15, 15, 15, 15, 15. This data set also has mean of 15, right? There could be another data set, let's say 12, 13, 14, then we can have 18 and 18. This data set also carries the mean of 15, right? In the similar way, there can be n number of data sets that can have mean of 15, right? And this n can go to infinity as well. I can give you infinite number of data sets that can have the same mean, same number of elements and same mean. You can have same mean but different number of elements as well. This will also go. Let's say, for example, mean of 30, let's say, sorry. For example, let's say mean of 16 and 14. This is also 15, right? The number of elements are two only. I can have, let's say, three elements, right? For example, let's say I can have, let's say, 14, 16, and 15. This also has mean of 15, right? This will also have the mean of 15. How will I, let's say, get to know, right? How will I differentiate these two data sets or any two data sets for that instance? If I only give you the information of mean, because all of these data sets are carrying the same mean, right? This is where the concept of average squared distance comes into picture. Average squared distance, right? What is mean? Mean is the average distance. Mean is the average distance, right? Average squared distance, like how we represent mean as summation of I equals to 1 to n xi by n. This is the mean of the data. This is the mean of the data. In the similar way, or this is also referred to as the average distance, right? In the similar way, we have something called variance, right? Variance is basically represented as summation of I equals to 1 to n xi square by n. This is variance, right? This is the average squared distance, right? And this particular figure, it tells you about the spread of the data. It tells you about the spread of the data, how your data is spread, how your data points are spread. Variance tells you about that. But again, here, there's a problem. Right? Every data point, let's take the same example that we are considering. Right? Let's take this example only. Here, the mean of the data set is 15, and all of these data points have the same mean, which is 15, I can further differentiate this particular data point, or the data point that I have to deal with, right, on my current data set. If I calculate the variance, the mean can be same, but the variance and mean for all these data sets cannot be same, right? You'll have a different variance between all of these data points, because here we are not only calculating the average distance, but in addition to calculating the average distance, we are also calculating the average squared distance. This is going to be the first step that is going to differentiate between my data set and other similar data sets that have the same mean, right? Now, the thing is, this term is called variance, but since if you remember, we talk about shifting of the data points or shifting of the reference point, right? So if we shift the reference point, right, if we shift the reference point, this can equivalently be written as this: I equals to 1 to n xi minus 0 whole square by n. Here 0 is representing the reference point, right? And this reference point is nothing but origin of the data, right? So this reference point is the only point we are going to change, right? Which is why we are going to make a little change in the formula itself, and this formula will be derived like this. Which is, just minimize so that you can compare. Okay, so here this particular formula is going to change like this. Summation of I equals to 1 to n will remain as it is, right? Now the second thing is xi will remain as it is. We are only going to change the reference point, which is this. All right, followed by, we'll subtract it with mu, take the square and divide it by the total number of elements. All right, so this is how your formula of mean is going to change. All right. Now, the thing is, as the formula changes a little, right? Which is why to differentiate between these two formulas, there are terms associated with these, right? And the terms are a different color. Let's take green, right? So this particular term is called crude variance. All right, okay, let me write it. All right, so here, this particular formula is referred to as crude variance, right? And this particular formula is called centered variance, right? Every time you're going to calculate the formula, or whenever you need to calculate the variance, right, you're going to use this particular formula every single time, right? There's one more variation here, which is sampling adjustment, right? Where this n becomes n minus 1, right? This is because of the sampling adjustment. You learn about the difference between samples and population, right? So this is for population. All right. And this particular formula further changes. Let me. Right. This particular formula further changes like this. The formula becomes I equals to 1 to n. This will remain as it is. Right. Xi minus mu will remain as it is. The square of the term will remain as it is. Only the denominator changes from n to n minus 1. Right. This particular formula is the centered variance for samples. All right. Now, there are a few, let's say there are a few, this purely depends on what tool you're using to calculate, and based on that only formulas, respective formulas are used, right? I'll give you a little scenario about this. Let's say whenever you're going to use, let's take black, right? So whenever, if you're using Excel, right? So this particular formula is used to calculate the variance. If you're using NumPy in Pandas, this particular formula is used, right? So this purely depends on what tool you're working, and based on this tool only, you're going to get the output. Right? So you learn this with the time that based on various tools that you're using, different formulas are used to calculate the outputs. Right? Even the stats, there's a model called SciPy, which stands for scientific Python. Whenever you want to do any scientific calculations, right? Maybe the statistical models that you want to build, right? This particular module will be used. Right. Earlier, there was a module purely dedicated for statistics only called stats model. Right. This has been deprecated as of now, which means this is no further being developed, and this is replaced by SciPy. Right. So these are the two formulas that various, let's say, various tools use to calculate the respective outputs. All right. Now, there is one more term associated with this. I hope everyone is able to understand this. You can simply raise your hands to confirm. If any one of you is facing any issues in understanding, you could let me know your doubt in the chat section, right? I'll try to come up with your doubts. Okay, so one of you is asking to explain the mean calculation manually using 25 data points using the mean formula. So this is your homework, right? You simply create 25 data points, right? Let me give you this homework, right? The first step is, let's say you have to create 25 data points, right? These data points can be any value. It can hold any value, and you have to calculate mean on pen and paper. All right, this is your homework, right? You can use, and your hint is you can use this particular formula, which is summation of I equals to 1 to n xi divided by n, right? This is a formula that can be used to calculate the mean. All right, now let's proceed ahead. Okay, so yes, of course, you can use the salary from last data, right, to calculate the variance, mean, etc. Right? That is absolutely not a problem. All right, so these formulas are different, and these are going to give you different values as the output. You have to understand this. If you divide, let's say in both of these formulas, if you look closely, right? If you look closely, there's only one difference, and the difference is of the denominator only, right? Only denominator is different, right? So for example, let's say if you divide 75 with 5 and in other value you divide 75 by 4, you will end up getting different values. You have to understand this, right? If you divide a denominator with a smaller value, this will be higher. Let's say this will be greater than 15, because here you're getting 15, right? So this is greater than 15 always, because the denominator is less, right? You can understand it this way. Let's say if you divide 75 by 1, this will be 75, right? If you divide 75 with 2, this will be, let's say 30, sorry, yes, it is 37.5, right? If you divide it by 3, this is going to be 25, right? So as the denominator is increasing, this particular value is decreasing, right? In the similar way, if you divide it by 4, you'll get value greater than 15, because while dividing it by 5, you're getting the value as 15, right? So these two formulas are going to give you different values. If I ask you on Excel to calculate variance, you can directly use in Excel, although in Excel you have different formulas for sample and population, right? But in statistical tools like NumPy and SciPy, which you'll use in Python, these do not have different formulas, right? They'll directly give you the value. Here you get the option to select the function, whether you want to calculate it for population or you want to calculate it for samples. If you will calculate for population, this formula will be used. If you'll calculate for samples, this particular formula will be used. I'm talking about Excel here, right? At the same time, if you in NumPy and SciPy, there are direct functions like np.var. This will directly give you the variance. It will not ask you whether you want it for population or sample. This will directly give you a value, right? And this value will be your variance, right? So you have to understand, you can always go through the documentation, always go through the documentation. Documentation will help you to understand what formula actually in this var function is using, right? You'll easily get this idea what this like what formula has been used, right? So that in case you think that you want some other output, or maybe the case study that you're handling needs some extra attention on the formula, you can recreate a formula by yourself, right? Where you can include, instead of n-1, you can simply include n, right? So this can be done. Yes, in this formula, mu stands for mean of the data. All right. Okay. So, right. So, okay. We have a valid question here. How do you decide whether you have to use the population or the sample formula, right? So when you're working on the raw data set, every data set is considered as sample, right? Why it is considered as sample? Because population is basically your complete data set. When I say the data set is complete, in technical terms, it basically means that no data can be inserted. No data can be inserted, and neither the data can be removed, right? The data cannot be inserted and cannot be removed if it is considered as population, right? At the same time, if it's considered as sample is nothing but this is the subset of population. Here, the data can be inserted and removed based on your need, right? So always in statistics, in machine learning, we considered our data set as samples, right? Until and unless it is strictly mentioned to consider the data as population, we are not going to consider it as a population. All right. And since sample is a population, let's say your data set, for example, let's say 1, 2, 3, 4, 5, right? This data set can be population, and the same data set can be sample, right? This purely depends on the case study you're handling, the problem statement you're dealing with, right? This purely depends on the problem statement you're dealing with, and your sample can contain the complete population as well. There is absolutely not a problem, right? Since sample is a subset, this is the subset, right? And subset can hold the complete data set as well, which is why this particular data set is to be considered as a sample or as a population. This purely depends on the kind of data you're dealing with and the problem statement you're working on, right? So you'll learn this difference and you'll establish this difference with time in data analysis with Python. You'll understand what exactly is the difference between samples and population and how you're going to select whether you have to work taking your data set as population or you have to work by taking your data as samples. All right. So this is the difference. And right. So yes, this is the part. All right. Now take 5 minutes of break. After that, we'll discuss about the third moment, which is the skewness of the data. All right. And at the end, we'll summarize each and every formula that we have discussed in this particular session so that you get this idea how formulas are different and how they can vary based on the data, right? So please take a 5 minutes break and then we'll proceed ahead with the discussions sharply at 5:40. All right, guys. So let's proceed ahead with our discussions further. Let's discuss about the third moment. All right, just give me a moment, guys. I need to restart my pen, right? Just give me a moment. All right, so let's proceed ahead with our discussions. Right, and now we are going to discuss about the third moment. Third moment is referred to as skewness. Right, so basically skewness, as your, I'll just give you a quick brief, like how your mean tells you about the average distance, right? Or this basically gives you the average value of the data. How your variance tells you about the average squared distance, right? Or it also tells you about the spread of data points. In the similar way, we have skewness, right? And skewness tells you about the biasness. Skewness tells you about the biasness, and this biasness is nothing but the domination of the values, right? Now, moving ahead, like how we can easily calculate the mean of the data by simply taking the sum of the numbers, dividing it by the total number of values. How we can calculate variance by simply taking the sum of squared numbers, which is xi square, and dividing it by the total number of values. In the similar way, we can calculate the variance of the skewness of the data set by simply taking the sum of cube values, which is xi whole cube divided by n. Right? And this value basically tells you about the biasness, right? Or this is also known as tiltedness, right? So towards what values your data is tilted, or your decisions can be, let's say, tilted towards what values, skewness tells you about this, right? Ideally, I'm talking about the ideal conditions. Ideally, your skewness of the data set should be 0. Ideally, right? And if the skewness is 0, it is considered as the normal distribution, right? I'll just give you a brief about normal distribution because you're going to cover the normal distributions in detail in your data analysis and advanced statistics sessions. Let's say if the shape of my data is like this, which is a bell-shaped curve. This is a bell-shaped curve. Right? The center of this data represents the mean of the data set. Right? This represents the mean of the data. Your data is equally distributed towards the right and towards the left with respect to mean, right? If it is, so this particular data set is a normal distribution. Apart from this, let's say if you plot your data and the distribution of your data set, let's say looks something like this, let's say like this, right? Or it looks something like this, then these two data distributions, they have skewness, right? They have skewness in the data and it has to be removed, right? And skewness is basically removed by carrying out the transformations on your data, right? So you learn about the transformation techniques that can be used to remove the skewness in your machine learning part. Here we are totally focused about understanding what skewness actually is, right? So as already informed that this is the formula that you're going to use to calculate the skewness of any given data, right? So let's say you can simply take the same data set that we have been taking since mean of the data. So this is 12, 14, 14, 17, and 18, right? Here we saw the mean of the data was 15. If you calculate the variance of this data, this will come somewhere around 225, right? At the same time, let's say if you calculate the skewness of this data, you'll get a value, right? You'll get some value if you take simply cube this number, cube this number, cube this number, and add all of them together, divided by 5, you'll get some value, right? So this value will come somewhere around maybe 1300 or 1400, right? Somewhere around 1400, roughly equals to, this is roughly equals to 1400, somewhere in between, right? So this is the skewness of this data and it has to be removed, right? So there are multiple ways to remove it, but what this skewness basically tells us that the data is not normally distributed. If my skewness is not equals to 0, this clearly says that data is not normally distributed. Right. And if my data is not normally distributed, the things that I cannot do, is the first thing is I cannot build a statistical model. Right. I cannot build a machine learning model. Right. I cannot do these things because my complete statistics and machine learning has been developed in such a way that it is only developed for normal distributions. Right? It is only developed for normal distribution. If you look at the data that we were already working with, the employees data set. If you plot, let's say, salary distributions, I hope everyone saw. Let me just just reopen that. Give me a moment. I'll just reopen and show you. Okay, so this is the data, right? Now, if I plot my complete salary column into, let's say, a histogram, right? So let's say this is the histogram, right? Now here, if you see, this data does not have a normal distribution, because if you take the center of all these data points, let me just, right, if you take the center of all these data points, let's say center of all the points here, right, like this, these are the center of these buckets, right? So this will start from here, it will go like this, go like this. This is the maximum, right? It will go like this, and something like this. This will be the distribution here, right? If you, let's say, you can simply add, the plot here. Let's say with respect to this, if you add, you can basically, let's say, add the line plot as well into the same data set, right? You'll be able to see that a similar graph like this, right? Right. So this is not normally distributed, because my how my normal distribution looks like, it should start from here, go on like this, and finally like this, right? So this is my normal distribution, right? So let's say if you work on this particular data set that we were working on, right, this employees data set into machine learning algorithms, you have to convert this particular column, which is my salary column. This is my salary column. You have to convert the salary column into normal distribution, right? So basically, you have to remove the skewness, and there are transformation techniques those are used. You learn about the transformation techniques. We have like power transformer, right? We also have, let's say, Box Cox. We have Yo-Johnson. There are multiple types of transformers, those are used, and these will transform the values of these individual data points, right? So that your distribution can be converted into a normal distribution. All right. So this is not due to the missing data. The data set is not missing, or anywhere the data is not missing, right? If the data is missing, there's completely different concept, use imputation, right? It's known as imputation, where we basically impute or fill out the missing values. But here the data is not missing. For example, let's say if you see to the registration date here, sorry, not the registration date, but the resignation date, this particular column, there are multiple rows where data is not present. This is missing data. This data is missing, right? We'll fill out the values before proceeding ahead to build a machine learning model or train a machine learning algorithm, right? So this is how your normal distribution looks like. And the one mentioned in the blue line, this is basically where skewness is present, right? You can directly calculate the skewness on any column. Let's say, right? Let's say if I want to calculate the skewness, let me pick maybe this particular cell, right? I can directly calculate the skewness. I'll simply mention the skewness, right? And I'll simply pass the salary column. This will tell me this is the amount of skewness that is present into this particular column, right? So this is the skewness that is present, and I need to remove this skewness so that it should be equal to 0, or at least it should be as close as to 0, right? Ideally, let's say talking practically on real-time data sets, you cannot remove the complete skewness. So what we do is we try to bring the skewness as close as to 0. So 0.8 is a very high skewness. You can reduce it to as close as to 0. Maybe if I'll be able to reduce it to 0.01 or 0.02, that amount of skewness is far better than 0.88. Right? So you learn about how to remove the skewness. The thing is, you have to remove the skewness because every distribution of the data has to be converted into normal distribution. Right? And you can only calculate skewness or basically all the moments, right? You can only calculate skewness, kurtosis, mean, or let's say the variance of the data only on the numerical columns, only on continuous data, right? You cannot calculate on categorical data. You cannot calculate. For example, let's say you have a gender column, which is a categorical data, right? Here, there are two genders present, male and female. Let's say if I ask you, what will be the mean of male and female, right? You won't be able to answer because you cannot calculate mean of male and female, right? Because these are categorical columns. At the same time, let's say if I have maybe the country column, right? I have the country column. Name of the country is present. Maybe I have, let's say, China, right? I have US, I have, let's say, Brazil, right? I have India. So if I ask you to calculate the mean of all these values, you won't be able to calculate, right? Because these are not continuous data, right? If I ask you to calculate, let's say, the mean of China, India, right? US, and maybe Brazil, right? So you won't be able to calculate because this is a categorical data. This goes generalized to every column that is categorical in nature. You can only calculate on continuous data, and the continuous data in your data sets are the salary column, you have the age column, right? And you have, let's say, the hike, the percentage of hike any employee has got. It's a numerical figure, right? So you can calculate on this, but you cannot calculate on categorical data sets, right? We have something called as encoding that you'll again learn in the, we have something called encoding where we basically transform the categorical data into numerical formats, numerical representation, right? Once you are able to transform this into numerical representation, then also you cannot calculate skewness or any moment for that matter. You cannot calculate moment, right? Because let's say if I replace male with 1 and female with 2, right? So if I again ask you to calculate the mean of male and female, you cannot do that, right? At the same time, if I ask you to calculate the mean of 1 and 2, you can of course do this because this is mathematically, these are numbers, right? But again, these are representing male and female only, right? So question goes down to calculating the mean between male and female, right? So since you cannot do that, which is why you will not be able to calculate the skewness or any moment, right, on categorical data. All right, so let's proceed ahead. Let me give you a walkover of the skewness, right? So skewness technically can be calculated as I equals to 1 to n xi whole cube divided by n, right? Now, the second thing is this is crude skewness. Crude basically means raw, right? So the raw form of skewness that is being calculated. This is crude skewness. This can be, since here reference point is taken as origin, what we'll do is we'll simply take the reference point as mu or the origin mean of the data. We'll simply take the cube and take the summation 1 to n and again divided by n. Right? This is referred to as center skewness. All right. Now, there's one more thing that can be done is I can standardize this. And how I can standardize this is basically I again take summation of 1 to n, right? X minus mu will remain as it is, right? This 1 by n will remain as it is. And what I'll do is I'll simply divide it by the cube of standard deviation. This is standard deviation, right? And this standard deviation is nothing but the standard deviation is nothing but square root of variance. Right? Standard deviation is nothing but square root of variance. By dividing it by the standard deviation, this is called standard deviation, right? By dividing by it by the standard deviation, I'm removing the dependency of all the data points on the average of the data, which is mean. So this is why it is called standardized skewness. Right? This is the standardized skewness. And finally, only one thing needs to be done is I have to remove or I have to add the sampling adjustment, which means instead of dividing it by n, I have to replace it with the sampling adjustment, like how we did in case of variance. We replaced this with n minus 1. In skewness, since we are taking the cube of all the data points after subtracting it from the mean of the data, so the amount of sampling adjustment that will be added will be a little more, right? So let me just walk you through that as well. So the sampling adjustment that will be added, basically this part will remain as it is, which is summation of, right, summation of I equals to 1 to n xi minus mu whole cube divided by the cube root of standard deviation, the cube of standard deviation, and the amount of sampling adjustment that will be added is, in place of 1 by n, I'll simply replace this with n by n minus 1 multiplied by n minus 2. This is the sampling adjustment that has been added. So this is the final formula for skewness that is to be used. This is centered, standardized, right? Skewness. And this is for samples, right? This is centered, right? The centered standardized skewness for population. Right? So every time you need to calculate the skewness, you can use this particular formula, right? On the internet, you'll find all these 4 formulas for skewness, but you need to understand under what circumstances, what formula has to be used. All right. So these are the 3 moments. Those are very important with respect to statistics, with respect to data analysis, with respect to machine learning, and with respect to data science, right? So you need to, let's say, understand the intuition behind these statistical methods. And if you are able to understand these 3 moments very clearly, the rest of your machine learning journey is going to be very smooth, right? Otherwise, you'll face problems when we'll discuss about outliers, when we'll discuss about z-score, right? When we'll discuss about transformations, when we discuss about removing skewness from the data. At every stage, you'll face difficulty if you're not able to understand the intuition of mean, variance, standard deviation, and skewness. Right? So these 4 statistics are very important with respect to understanding machine learning and with respect to carrying out the data analysis. All right. And there is also a 4th type of skewness. Okay. So centered skewness is for population, right? This is for population. So real world applications will be very soon clear, right? When you'll proceed ahead with data analysis, this part of the concepts will be clear to you. All right. Since there are a lot of things involved in data analysis, hence we are covering these topics one by one, right? And there's also 4th type of skewness, which is never used, and which is why it is not important with respect to understanding, or it's not very much used, right? And that part is kurtosis. Right? That part is kurtosis. Like how skewness tells you whether your distribution of the data is towards left or right, in the same way, kurtosis tells you about, this is the 4th moment, by the way, right? In the similar way, your kurtosis tells you about the peakedness of the distribution, right? So let's say this is the distribution, right? For example, let's say this is the normal distribution, right? Now, if the peak of this distribution is a little higher, your data will shrink out, right? So this will look like this. If the peak of your data is, let's see, is yellow, orange. All right. So if the peak of your data is very much closer to the axis, your data will further spread out, right? So your peak will look like this, right? So the one that is mentioned in green color, right? The one that is mentioned in green color, this is your normal distribution. All right. These are your non-normal distributions. All right. So although the peak of the, or the peakedness of the distribution is not very much important, which is why the kurtosis is, there will be hardly any cases where you use kurtosis, right? But just because it exists, which is why I'm walking you through here on this particular session. All right. So let me just give you the formula as well, since I'm walking you through, right? So the kurtosis is calculated using summation of I equals to 1 to n. We'll simply take xi, take the 4th power of this and divide by the total number of observations. This is your kurtosis, right? And as usual, this is your crude kurtosis, right? Here, it can be transformed to centered by simply subtracting each of the data point from the mean of the data, taking the 4th power, dividing it by n. All right. This will go from 1 to n. Right. So this is your centered. All right. Now, we can again standardize this by simply dividing it by the standard deviation. All right. So this will further change to I equals to 1 to n xi minus mu fourth power, right? Dividing it by the fourth power of standard deviation. All right, and 1 by n will remain as it is. Right, so this is your standardized, and this is as well as this is centered as well, right? This is centered kurtosis. And all of these are for population. This is for population, this is for population, this is also for population, right? Now, the final thing is you have to add the sampling adjustment, right? So this is the sampling adjustment that will be added. So rest of your term will remain as it is, right? So what is the rest of the term? So let's say summation of I equals to 1 to n xi minus mu to the power of 4 divided by the fourth power of standard deviation. This will remain as it is. Now there is a sampling adjustment that will be added, which means 1 by n will be replaced with a certain number of terms, and these terms are n into n plus 1 in the numerator divided by n minus 1, n minus 2, and n minus 3 in the denominator, followed by there will be an additional term that will be subtracted, which is 3 times n minus 1 whole square divided by n minus 2 and n minus 3. Right, so this is the formula for kurtosis, right? And this is again standardized, centered, right? Kurtosis along with sampling adjustments. Hence, this is for samples, right? So I've already informed, nobody has to remember these formulas. These are just for your conceptual understanding, right? If you, let's say, if you will easily be able to walk through all these formulas very easily. That will absolutely be not a problem. The only idea is to get the intuition behind all of these statistics. All right. Now, let's proceed ahead and let me give you the list of all the formulas in the form of a summary that we have discussed today. All right. So here, basically, we have 4 moments. All right. So this will be your first moment. This is your second moment. This is your third moment and fourth moment. All right. Now, the thing is, in the first cell will simply mention what do they basically represent. All right. In the second column, we are going to mention the formula for crude values, right? So for example, let's say if this is your first moment, okay, so let's add one more column here. Give me a moment. Here we'll simply mention the name of the moment. Here we'll simply mention what they basically represent. All right. In the third column, we'll mention the crude value or crude formula. The next column will mention about the centered formula. The next column will mention about the standardized formula, right? And finally, we'll mention about the sampling adjustments. the formula for samples, right? It will be combination of centered and standardized along with the samples or the sampling adjustment. All right, so let's proceed ahead. Learning about this, right? So the first moment, it's basically referred to as, this is the mean of the data, right? This is the technical term. This basically represents the average value of the data. Right, this represents the average value of the data. The formula that is used to calculate the crude form is summation of I to n xi divided by n, right? Where n is your total number of elements, right? There is no centered, because how centered formula is calculated is by simply subtracting the mean of the value, right? So here we cannot apply the centered formula while calculating only, right? Because if you subtract mean from itself, you will end 0, right? In the similar way, standardization cannot be applied and no sampling adjustments. All right. Now, the second moment is referred to as the variance of the data. It tells you about the spread, tells you about the spread of the data, right? The crude form of the formula is summation of I equals to 1 to n xi whole square divided by n. Simply have to take the square of every term, add all of them together and divide it by the total number of elements. All right. Now, there's a centered form of this where we'll simply subtract each of the elements from the, where we'll simply subtract each of these elements from the mean of the data, right? So this part will remain as it is, which is summation of I equals to 1 to n. Xi will change to xi minus mu, which is the mean of the data, right? This is mu, mean of the data. Take the square of the terms and divide it by the total number of elements, which is n. All right. Now, third is the standardized form. So standardized form cannot be calculated. Why? Because standardization or the standard deviation is basically calculated by simply taking the square root of variance. And since we are calculating the variance itself, right? And if you take the square root of variance, you'll end up getting the standard deviation, which is used as an extension in every formula to calculate the standardized form, which is why we cannot calculate on variance, right? So we have the sampling adjustments, and the sampling adjustment is done as follows. Is basically you'll simply use summation. I will go from 1 to n, will take xi minus mu, which is the standard, which is the mean of the data. Take the square of the terms. That is done is will simply replace n with n minus 1, right? So this is the sampling adjustment that is done. All right. Now let's calculate the standard, the skewness All right, so how skewness is calculated, which is the third moment. Right, your third moment is called skewness, right? And it tells you about the biasedness or tiltedness of the data. The crude form of the formula is calculated using summation of I equals to 1 to n xi raised to the power of 3 divided by the total number of elements. Right, so this is the crude form of formula that is used. Then we have the centered form of formula for this, where we'll simply replace xi with xi minus mu. Right, so I'll simply replace xi with xi minus mu. Hence, the formula will change. It will go from 1 to n xi minus mu raised to the power of 3 and n remains as it is. This is the centered form of the formula, right? Then we can calculate the standardized form of this by simply dividing it by the standard deviation. So this part of the formula will look like this. It will go from 1 to n, right? Xi minus mu whole cube divided by the standard deviation q. All right, and 1 by n will remain as it is. Right, then we have the centered and standardized part. The sampling adjustment part, right? Yeah, this is the sampling adjustment that needs to be done on this particular formula, and the amount of sampling adjustment that needs to be done is as follows. We'll simply keep the rest of the term as it is. The summation of I equals to 1 to n xi minus mu whole cube divided by the cube of standard deviation. So, right, and the sampling adjustment that will be added to this is n divided by n minus 1 into n minus 2, right? And finally, we have the kurtosis part. Right. Finally, we have kurtosis. Kurtosis basically tells you about the peakedness. Right, and peakedness, or basically kurtosis, the crude form of it can easily be calculated using I to xi raised to the power of 4 divided by n, which is the total number of elements again, followed by, this is the centered form, where we'll simply replace x with x minus mu. Right, so this will be xi minus mean of the data raised to the power of 4 divided by n. right? Next is the centered plus standardized, right? Here, what we'll do is we'll simply divide the term by the standard deviation, right? So we'll simply mention xi minus mu raised to the power of 4 divided by the standard deviation raised to the power of 4, and 1 by n will remain as it is. All right. And finally, we'll add the sampling adjustment to this, right? Yeah. So the sampling adjustment that will be added is, this is n into n plus 1 divided by n minus 1, n minus 2, n minus 3, right? Followed by the summation of I equals to 1 to n. This will be xi minus mu raised to the power of 4 and divided by the cube of, fourth power of standard deviation. And we have one additional term, which is we'll subtract this complete output from 3 times n minus 1 whole square the complete set of all the formulas. Those are right, and based on these scenarios and your, let's say, problem statement, you're going to use these formulas. So, right, if anyone wants to take the screenshot of this, you're free to do. Right, this is the complete set of formulas that can be used. Right, and this is the summary of moments. Right, you don't have to, let's say, right, you don't have to, let's say, go through the formulas, right? You don't have to remember the formulas. This is just for your conceptual understanding. All right, and this, I've just summarized this into one single part, so that this will help you to establish the differences between this, right? In crude, you'll have the raw form of the moments, right? For example, summation of x raised to the power of 4 by n, right? In the similar way, in centered, we'll simply replace x with xi minus mu, right? We'll simply subtract every individual element from the mean of the data, right? So here, xi minus mu whole square by n, xi minus mu whole cube by n, xi minus mu raised to the power of 4 by n, right? In the standardized, we'll simply divide it by the standard deviation, right? So since we are calculating skewness, which contains the third power of the difference between mu and the data point, hence we are dividing it by the cube of standard deviation. In the similar way, in kurtosis, since we are taking the fourth power, we are simply dividing it by the fourth power of standard deviation, right? And in the sampling adjustment, we are basically adding the amount of sampling adjustment that needs to be added so that my data set can be considered as sample, right? So this is the sampling adjustment that is being added. All right. So yes, guys, with this, we are wrapping up the session for today, right? I hope everyone is able to understand these concepts, because this will help you in long run. All right, so one of you is asking, do you need to follow the sequence for mean, variance, skewness, and kurtosis in data analysis? So the answer to this is yes. You'll follow this particular sequence, because once you calculate the mean, variance, and let's say standard deviation along with the skewness, you'll be able to understand a lot about the data set that you're working with. All right. So yes, although the order is not important, but if you calculate skewness first and then mean, that will absolutely not affect any of your, let's say, understanding the insights, right? The thing is, you need to calculate every individual of these moments to understand the insights of your data. The information that you can extract will basically be more detailed and you'll be able to extract better information from the data sets. All right, so the practical implementation of this will be covered in your machine learning part, because there are a lot of things that needs to go in to understand the data analysis part. All right, if you want, I can show you the implementation of this in MS Excel on the same data set that we were working on, which is the employees data set, right? So you'll get a little idea about how these topics or concepts can be used and utilized. Yes, this will basically help you to build the solution for the basically, see, in case of data analysis, there are multiple small problems that you'll be working on, right? There will be eventually a big problem, and to get the answer to that big problem, you have to break down your bigger problem into various small problems, right? And then you have to find the solution of these small problems to get the answer to the bigger problem, right? This is eventually the complete data analysis that is to be done. Right. So next class we'll be discussing about covariance and correlation, which is part of your inferential statistics. In the initial half an hour, I'll just walk you through. We'll calculate all of these moments using the data set, which is employees data set, and eventually we'll move on with the correlation and covariance. All right. So this way the sessions will be connected. And tomorrow also we are going to have the session on the same time, which is 4 to 6. In addition to these 4 to 6 sessions, these are your extra classes that is being conducted, right? And apart from this, on your regular timings, which is 9:30 to 11:30, you're going to have your next module, which is programming foundation, right? So I have already walked you through that particular this particular information in the last session itself. All right. So yes, guys, thank you everyone for joining the session, and you have a good day.